Hi everyone, this is Mr. Kachinga. In this video we'll look at the standard equation of the circle. So you can pause the video, try to derive the standard equation of the circle. So the most important thing is to understand what is this standard equation of the circle. So when we have the center of the circle at any point rather than the origin, then such equation is called the standard equation of the circle. So in simple ways, the standard equation of the circle, it is the equation of the circle whose center is not at the origin. So when the center is not here but elsewhere, somewhere there, okay, it can be a circle here, then the center is here, then such a type of equation will be called the standard equation of the circle. So now, when we have the circle, we have to understand that the total distance around the circle, it is called the circumference. Now, let's say I have a point from the circumference going to the center like this. Okay, let's say here up to here, this is my O, I label it O and A. So the line from the circumference to the center, we know it is called what? It is called radius. Now suppose I extend this line a bit and this line I join them, we can observe that this line is horizontal and this line is what? Is vertical. So when two lines they are meeting like this, they form a what? A 90 degrees. So in this case we have a 90 degrees there, and then I name this to be what? To be B. Okay. Now let's say my center of the circle is here, and that center, it is in form of letters. Let's say H and a K. You see that? So my center is on O and I have H, K presenting my what? My center, while R presenting my radius. So I hope you are following me. So you need to pay attention to the details. Now, on point A, I decide that they should point X and Y presenting any point along the circumference of the circle. So, what can we do for us to derive the standard equation of the circle? So to derive the standard equation of the circle, we have to know the side of this right triangle A or B. So the first thing to do, we know that OA is equals to what? To R. You see that? OA is equals to R is equals to radius. What of OB? So here the distance OB we don't know. So let us find distance OB. We can do that by extending some point going to join the x-axis. So when we extend the lines like this and I extend another line like that, okay, take note that this is the what? The x-axis. So let's say here I have point X presenting X units. Then again here there is H, K, but this H, it is presenting the x-axis. So we can also put H there. Now, how can I find the distance between X and H? I can find that by subtracting X, take away H. You see that? So why subtraction? Okay, I want you to think of numbers. Let's say if here I have 4, then here I have 10. How can I find this distance between 4 and 10? I would just say 10 minus 4, then I'll find the distance. You see that? So that is the idea why I'm subtracting. So I will know that distance OB is equals to X minus H. So I'll write it this side. I'll know that there is X minus H. Another important distance is distance AB. So we can write AB. So AB we also don't know. AB we also don't know there. So AB we also don't know, but we can find distance AB. So how can we find distance AB? So first of all, we have to consider the y-axis going this side. We know it's a y-axis. So when I put dotted lines here and these dotted lines here, take note the distance from this point up to this point is the same as the distance from A up to B, but going this side it is y-axis. So it means here there is what? There is y. Okay. So if that side there is y, we also know that here there should be what? There should be a k. Okay. So why k? Because here there is point H and point K. Point H presenting the x-axis and point K presenting the y-axis. And how can I find distance y and k? So the distance which is there, we can simply also subtract it. You can just say y minus a k. Then that is the distance which is there. So in terms of numbers, suppose here I have 20 and here I have 15. So how can I find the distance between 20 and 15? I can just say 20 minus 15, then I'll find the distance which is on y and a k. So that is the idea. So this implies that on AB there is a distance of y minus what? Minus k. So AB therefore is y minus a k. Okay, now having to know the important details, we can use Pythagoras theorem to find the radius r. So by using Pythagoras theorem, if I want to find radius r, I can say OB, I square it. You see that? Then I have to add with AB squared, and this should give me OA, then 1 squared. So that is by Pythagoras theorem. You see that? Since triangle AOB is a right triangle. Now, we have gathered the information. OB, this OB, we know that it is x minus h. So we are going to put x minus h, we square it, then plus AB. Okay, now what is our AB? So our AB, it is y minus k. So y minus k, we square it, then equals, what is my OA? My OA, it is radius. Okay, then we do what? We squared. So hence derive. So this is the standard equation of the circle whose center is not at the origin, when the center is not at the origin. So thank you for watching. In the next video, I'm going to show you how we use this equation, the standard equation of the circle. So this is part 1. There will be part 2 of the video. Thank you for watching.